Time ago, I was looking for a good theme for modeling rounded boxes. I found out about the shaker-style pantry boxes in Wikipedia. The Shakers were a branch of the Quakers, and as you can read in Wikipedia's article,
the shaker-style pantry box is a round bent wood box made by hand. Such boxes are associated with Shaker folk life because they express the utility and uniformity valued in Shaker culture. The bent wood box was originally a working box for storage of dry items, but today is used more as a decorative item. The Shakers originally used the boxes for storing kitchen ingredients and small items and parts for the shop. They stored easily, as a smaller one could be put inside an empty larger one, as in Matryoshka-style nest. Many smaller boxes could be stored within the space of the largest box.
and this is how I ended up making the material bent wood box with Substance Designer. I've tried to make the material suitable for any kind of object. Here, I'm using the default objects which come with Substance Designer. I'm using the generated height map for displacement, with no modification of their unwrapping nor their geometry. This is why you might see some flaws in the top of them. Even so, you have several input parameters to fit the height map to your object's geometry. Here you can see the material in the Marmoset Toolbag 3 viewport. The top box has tessellation applied to it and is displaced with the height map. The bottom box is viewed with parallax occlusion only. This is the 3ds Max 2018 viewport. No displacement is used here. Only the normals map and the ambient occlusion one are doing the job. There is no direct light either. Only an HDR image is lighting the scene. In the slate editor we can see a single substance material generating all the maps for the two boxes of different colors. This is an unfinished scene in Unreal Engine 4.18. There is no displacement, but only a kind of parallax occlusion. The textures are pre-generated and compressed in DXT1 format, with a resolution of only 1K by 512 pixels. I'm not a substance designer expert, and some aspects of this material presented a challenge to me. The trickiest one was the band's slope and to make it tileable. Let me show it to you by using the rounded cylinder. The rounded cylinder doesn't have a top. We will focus in the height map and will use tessellation and displacement to see the effect from the height map more clearly. The height map is not in the sRGB color space, but it is a linear bitmap, so we must deselect the color space in the texture viewer. Now, by means of the material's input parameters, I will fit the material to the cylinder's geometry. Firstly, in the wiring group, I'll disable the input pantry box's curvature map. Then, I will reclaim the entire vertical space of the textures for the bands. I should enlarge the cutting's horizontal size. Now it's time for the nails, their size, position and distance from each other. The important thing here is that you should notice the progressive slope of the bands and how each one is resting at the top of the next one. Even the interstices between bands must reflect this. This effect, besides making it tileable, as we'll see later, presented a real challenge. Let's remove the bevels in the bands, because it's based in a blurring effect on the height and normals map, and I want to see the transitions clearly in the map. We control the slopes ramp by means of three parameters in the band slope group: the start, the middle, and the end of the slope. The height starts increasing from the start of the band. Its zenith is at the middle point before the last nail, and finally it decreases again until the end of the band. Notice that one band starts long before the previous one ends, and so must do its slope. Let's revisit the slope's values. It must start at 0.1 and must end at 0.6. But you should know that I have the texture shifted for the cuttings to start at the center. In the information panel below, we can read the pixel values as we move the pointer along the map. Under the band's parameters group, we can shift the bands horizontally. I'll make them to start at position 0 to see the actual boundaries of the textures. The gradient should progress and tile gradually, accordingly to the parameters values, with no gaps between its boundaries and no matter where it starts inside the bitmap. This is the actual texture with no shifting. As you can see, the gradient starts where the cutting starts, not at the beginning of the bitmap. It should read 0.1 at the beginning of the cut, and should have approximately the same value at the end of the texture and where it starts, in this case 0.3. I do not intend to be too accurate with the pointer. The same should happen if we shift the start of the band, as before. .1. Here there is no gap. 0.6. .6 again. The middle point must be at 0.95, not being too precise with the mouse, and the slope must end at 0 0.6. As I said before, this was a good challenge, among others. The bent wood box material is actually two nested materials. The inner one is the bent bands material, which is the responsible for creating the bands, no matter which kind of simulated material will be produced at the end. It means that you could use it to create bands of steel, for example. The outer material also contains the American cherry wood material, which comes with Substance Designer. You can substitute it with any other wood, as long as you properly reconnect its outputs and publish the same parameters as the original does. In short, the bent wood box material mixes the wood and the band outputs accordingly, creates a new material of bent woods, and gives you the essential parameters to customize it. Not all the wood's parameters are exposed, but you can do it by yourself in case you need them. Let's see the outermost material, the bent wood box 1. It produces up to 3 different color maps for you to be able to texture up to 3 different objects with a single substance. You can also choose the color for the wearing effect for each one of them. In the normals map, you can choose independently how strong the bands and the wood's veins will be. You also have control over the strength of the ambient occlusion map. Notice how, as every other map does, it complies with the progressive depths of the bands. The roughness map, the metalness map, and the height map. In the height map you can control independently the position and range of the wood, the bands, whether to include the wood's vein in the bands or not, and how strong they will be. Now let's see the bent band's inner material. It generates the bent bands and its outputs are a combination of maps and masks, a curvature map, an ambient occlusion map, a height map, a normals map, of which the alpha channel is a mask for the nails, and a combined mask map with its 3 channels masking the nails, the cuttings, and the band interstices respectively. Let's take a look inside. You should notice how internally it draws a single band. This is the reason why it doesn't take dimensions as an input parameter, but an aspect ratio parameter instead. It means the length of the band with respect to its width. I advise you to keep it high enough. I'm using an aspect ratio of 8 by default. The package also includes 3 useful functions. One of them is for making a gradient with 3 keys or values. You can rotate and tile it, like the gradient node that comes with Substance Designer. But you can also specify the values for any of the 3 keys. And you can also reposition the middle one. You got it. This is how I've made the slope of the bands. Another function is for calculating the band's width given an aspect ratio input. This one I think is for converting the resolution steps of Substance Designer into real dimensions. Oh, and here there are 2 more for the map transformations. Sorry, it's been 2 years since I made this material. I think there must be more functions right here.